Kia ora Year 12 and 13 and Year 11. Here are a couple of questions from last year's complex numbers paper. Now I realise that I haven't YouTubed this yet, so I'm going to be trying to get through the questions over the next few days. So this one has got two questions. This is partly in response to one of my Year 9s who said that switching from one video to another was quite tedious. So I'm going to try and make them a little bit longer and put some more questions in. Hopefully that fits with your problems as well. The first question is an algebra thing, really. We need to know what the conjugate is, and we need to know how to deal with that, but after that it is pretty much straight algebra. And it goes like this. So we've got z is equal to a plus bi, and we're told that z over the conjugate can be written as c plus di. And we have to prove that c squared plus d squared equals 1. So the obvious place to start in here is to take this and to substitute it in here and see where we end up. So z conjugate is equal to a minus bi, giving me z over z conjugate equal to this. So it's going to be a plus bi over a minus bi. Now we know straight away that if we're doing division of complex numbers, we need to multiply both top and bottom by the conjugate of this. So we'll times by a plus bi. Let's see what we've got. Well, we'll put some brackets in to avoid silly mistakes. And now we're just expanding a quadratic in the numerator. I'm going to do this reasonably quickly. I'm thinking if you're watching an excellence video, I'm expecting your achieved skills are pretty strong. So we've got a squared plus 2abi, and then it's plus b squared I squared, which gives me minus b squared. And in the denominator, the whole reason we do this trick here is to get rid of the imaginary part. So we've got a squared, and not minus b squared, but plus b squared. Now let's rewrite that with a real bit first, and then an imaginary bit. So we've got 2ab over a squared plus b squared I. Now that's z over z bar, and we know from the question that that's equal to c plus di. Okay, so we have to show that c squared plus d squared is equal to 1. So let's work out first of all, what's c? Well, c is a squared minus b squared over a squared plus b squared. And d is equal to 2ab over a squared plus b squared. So let's now square each of these expressions and see what we get. And we're looking to end up with this. So on the left hand side we have c squared plus d squared is equal to this. So don't go expanding everything out until you've had a little bit of a look. So c squared plus d squared there we go, there's that one squared. Now I'm not going to expand the denominator. I'm going to leave that like this, because if we want to end up showing that this is equal to 1, what we want to do is to have whatever turns up on the top line simplifying down to this. So that's why I'm not going to expand all of that out. You could do it, it probably will work just about as quickly, but let's have a look at how this way works out. Right, what have we got for the expansion in the numerator? Well, I've got a to the power of 4 minus 2a squared b squared plus b to the power of 4 plus 4a squared b squared. Now, collecting up like terms gives me a to the power of 4 plus 2a squared b squared plus b to the power of 4 divided by this. Actually, I guess you could have expanded the bottom line, it would have been fine. Here, what I'm going to notice is that this is a perfect square, which is equal to a squared plus b squared. Right, a squared gives me that one, b squared squared gives me that one, and the middle coefficient is going to come from here. So look at that, we're done. That's the first question nearly done. So that equals 1 as required. Cool, so that's your first excellence question in the paper. And then question 2e went like this. The complex number u is equal to, there we are, that's better. The complex number u equals 3 plus mi is on the locus of points defined by this. Find the value of m. Now I'm hoping someone from last year's A-level class might be watching, or someone with a friend in that class is watching. I'm pretty sure that for this question you couldn't do it just geometrically. They wanted to see algebraic working. So I'm going to do this question using our kind of algebraic approach, which is to start like this. Let z equal x plus iy, and then I'm going to substitute in here. I just want to talk about how we can do that more quickly though, if we are comfortable. This is going to be the equation of a perpendicular bisector. Right? So graphically what we've got here is we've got the point 8 here, and the point, let's see, 4 minus 2i will be about like this. So this is saying the distance between the point and this one, and the distance between the point and this one has to be equal. So the midpoint of that is on the locus, and so is the rest of it. So the equation looks like this. And we can then go on and find that equation. But that's not the approach I'm going to take. I'm going to do it the long and boring way. So substituting in, we get x plus iy minus 8 is equal to x plus iy minus 4 plus 2i. So a straight substitution into the question. Now I'm going to reorder it with the real bits next to each other. So x minus 8 plus iy. That is always a good strategy when you're doing locus problems. Get your real stuff together and get your imaginary stuff together. And then we've got x minus 4 plus I times y plus 2. Now, the modulus of each side is the square root of this. So I'll do it slowly. We'll go x, the modulus of this side is x minus 8 squared plus y squared. And here we've got x minus 4 squared plus y plus 2 squared. Right. A really common mistake here that I bet some of you have done is to put this I into your modulus. Right? And that's incorrect because the modulus is measuring the distance of the point from the origin. Okay, so we don't want that I popping up in the modulus function. Squaring both sides gives me x minus 8 squared plus y squared is equal to x minus 4 squared plus y plus 2 squared. All we have to do now is to expand all of that on both sides and simplify. So we get x squared minus 16x plus 64 and so on. Right, it's worth checking that back quickly to make sure you haven't mucked up. Now the place that I often make a mistake is that in here, instead of writing plus 4y, I will sometimes, my brain will write plus 4x. So it is, just take 10 seconds to check that you haven't done any little expansion errors, and then we can start to clean up. Right, so the x squareds can be subtracted from both sides, and so can the y squareds. That leaves me with negative 16x plus 64 equals negative 8x plus 4y plus 20. Now you can see that this is going to be the equation of a straight line, so I'm going to go towards writing it in the form y equals mx plus c. What does that leave me with? I'm going to leave the 4y here, I'm going to add the 8x to both sides, giving me negative 8x, and I'm going to subtract 20, so it's negative 8x plus 44 is equal to 4y. Let's divide through by 4 and we get negative 2x plus 11 equals y. Right, so that's my locus, and you can see from that bad graph I did, oh, I've got rid of it. Hang on. Remember when I did this the geometric way? Here's my point 8, and here's my point, where was the other one? Let's think. 4 minus 2i was down here. All right, so you can see that this equation is exactly what we'd expect. It's the perpendicular bisector equation. Oh, that's a terrible perpendicular bisector. Anyway, what we have to do last is to use that equation because we're told that somewhere on that locus is this complex number. U is equal to 3 plus mi, and we have to find the value of m. In other words, when x is 3, what is y? So y is equal to negative 2 times 3 plus 11, which is 5. So m is equal to 5. Let's go over that just graphically. What are we talking about? Well, the complex number that's on the locus will be 3 plus 5i. So look here, and here it is up here. Alright, so that's the second of the excellence questions in that paper. I'll be back with the last two later on today. Thanks for watching. Please leave me any feedback or comments or things that aren't clear down below in the comments.